तो इथे आपल्याला काय दिसतंय की डेसिमल जो फॉर्म आपल्याला तयार करायचा आहे, तर इथे आपल्याला डिनॉमिनेटर बघायला लागणार. सेकंड सम मध्ये आपल्याला डिनॉमिनेटर बघायला लागणार. आता डिनॉमिनेटर काय दिलेलं आहे? डिनॉमिनेटर 11 आहे. आणि मग आपल्या नियमानुसार बरं का, आपल्या नियमानुसार जर डिनॉमिनेटर हा 2 किंवा 5 म्हणून काय बघितलं आपण की 2 आणि 5 असेल तरच टर्मिनेटिंग डेसिमल फॉर्म असं आपल्याकडे असतं, असं आपण बघितलेलं आहे. So here if we observe that terminating की नॉन टर्मिनेटिंग हे ठरवताना आपल्याला we have to observe the denominator. So in second sum we got that the denominator is 11, 2 upon 11. So we have to take the reason also as the denominator is not, or the factors of the denominator, we can say the factors of denominator. If the factors of the denominator are not 2 or 5, here we can take that line as the factors of the denominator is not 2 or 5. The decimal form, if we make the decimal form of 2 upon 11 is non-terminating. So we can continue the division and we find that the decimal form of the given rational number, that is 2 upon 11, is non-terminating. And whether it is recurring, we find out that. For that we should do that. So 11 is the divisor here and 2 is the dividend. So we can take group of zeros for here. Now 11 0, 0. So first quotient we get 0 and then point we get 0, 20. 11 ones are 11. Again we get 9. Next 0 we can take 88. 11 8s are 88. There we can take 2. 11 8s are. Now if you observe here that again we get this 2 as the next new dividend. So if we carry the division, we again get the quotient 1 and again get quotient 8. 11 8s are 88. Again we get 2. So this is our observation that therefore this is non-terminating but recurring also. So 2 upon 11 can be expressed as 0.18, and as this group is recurring 1 and 8, so we can take the bar over their head. 1.8, 1.8 dot 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 1.8, 1.8 dot 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 means 0.18, and for that 1.8 we take the bar over it. So it is non-terminating and recurring. Recurring means a digit or number of digits in the quotient occurs again and again. That is called recurring. Okay. Yes, please write down. So in this given sum, the rational number is given to you 29 upon 16. So if you find the factors of 16, 2 into 2 into 2 into 2, 4 times 2, 2 2s are 4, 4 2s are 8, 8 2s are 16. So only 2 is the prime factor. So we can write down that as the prime factor of the denominator 16 is 2, the decimal form, as per our rule or property, the decimal form of the given rational number, that is 29 upon 16, is terminating. Is terminating. So we can also solve that and then show that whether it is terminating or not. So as we just divide 16 ones are 16, we get the remainder 9 minus 6 is equal to 3 and 13. Point is should be given to the quotient form, 130. Okay. So 16 5s are 80, 16 9s are. So here we can take 16 7s are, if you observe, we get 112. Again, if you add 16, 16 8s are, 16 8s are we take here, that is 128. So 16 8s are. So as we can solve it, 16 8s are 130 minus 128, we get only 2. Then we should take the next 0. We get 20. Again, we get 16 ones are 16. Then we get remainder 4. We get next 0 for that. 40. 16 2s are 32. We get 8. Then again we need a 0. And as we know that 16 5s are, okay, so 16 8s are 28, 16 1s are 16, 16 2s are 32 and 16 5s are. So as the remainder is 0, the division is terminating over here. So therefore, as per our rule also, we say that it is terminating, and it is proved that it is terminating decimal form. 8125. 1.8125 is the decimal form, and it is terminating decimal form. Any question, any query? Yes sir, no sir, hello?
No, sir.
The next number given to you, 17 upon 125. What our rule says that we have to take the factors of 125. So if we take 125 can be expressed. If we factorize 125 can be expressed as 5 into 25, then 5 into 5. So 5 5s are 25, 25 5s are 125. So therefore, the prime factor is 5. Prime factor of 125 is only 5. So therefore, by our rule, as the prime factor of the denominator, as the prime factor of denominator is 5. What is the rule? If the prime factor is 2 or 5, then the decimal form, by our rule, the decimal form of given number, that is 17 upon 125, is terminating. 2 or 5. What would be the prime factors? 2 or 5, not other than 2 or 5. So if we observe that divisor is 125 and dividend is 17, we can take the group of zeros for that. So first is quotient is 0. Okay. So we get 17 over here. Then for point we can take the point and then take 0. Then 125 ones are 125. 125 ones are 120. In quotient we can write down 1. Then by subtraction we get 10 minus 5, 5, 7 minus 3, 4. So again we take next 0, 450. So 375. 125 3s are 375. 175 4s are 500. We don't have 500 for that. So 0 plus 5, 10 plus 5, 5. 2 plus 8, 7, then 0. We get 75. Then we take 1 0 over there. Then we have 125, 4 are, 125, 5 are, 6 are. 125, 6 are. If you observe here, 6 5 are 30, 6 are 12 plus 3, 15, then 6 ones are 6 and 7. So here we get the quotient 6. Okay. So 125 into 6, we get 750. So remainder is 0. So what is our observation here? We can write down, therefore, the decimal representation or decimal form of this 17 upon 125 is 0.136, which is terminating because we get remainder 0. At one stage we get remainder 0, means the division is terminates. Division terminates over here. So it is a terminating decimal form. Any question? So as the next number is given to you, 11 upon 16. 6 can be expressed as the prime factors. Product of prime factors 2 and 3. 2 into 3. So as the denominator, here what is your observation? As the denominator have prime factor other than 2, and other than 2, 2 and other than 2, that is 3 here. Okay. The decimal form, in this case, decimal form of the given number, rational number 11 upon 6 is non-terminating. Non-terminating. If it is the prime factor is only 2 or 5, then it is terminating. But as we get the 3 is also the prime factor, means other than 2 we get here that factor of denominator, then the decimal form of 11 upon 6 is non-terminating and recurring. So whether it is recurring or not, we can verify it by actual division. 11 is divided by 6, 11.00 we can take. Then 6 ones are 6. We start the division. 6 ones are 6. We get 5. Then point we should be given to the quotient section. 6 8s are 48. Here we get 2. We get again 0. 6 3s are 18. Again we get 2. Okay. Then again we get 2. Then we get 0 over here. Then again we get quotient 3. And this would be carried again and again as the new dividend is same, or remainder is same. So here the decimal representation, 6 1s are 6, 6 8s are 48, 6 3s are 6 3s are 6 3s are. So in this case, we can take the representation of the 11 upon 6 as the decimal form. We get 1.833 ... That is 1.83 is now here recurring. So we get a point over the 3 bar. 1.83 bar. So this is non-terminating and recurring form. If you observe this, okay. Yes, please write down. Question number 2 is given to you, that is, write the following rational numbers in decimal form. So to take the decimal form, we do actual division, even division. So 200 is the divisor here, and 127 is the, so 200 0 0. So here we can take the 0, then we take 127. So for decimal form, we should take the group of zeros after point. So point should be given in the quotient form, then we take 0. Now 206 are 1200. 206 are 1200. 2 6 are 12 and 2 zeros after that we get 1200. The table of 200 is easy. It is actual table of 2, and then we add 2 zeros to the numbers over there, getting numbers. So here we get 70, taking next 0, 700. 2 3s are 6, means 200, 3s are 600. So we get 100 over here. Then taking next 0, we get 1000. 2 5s are 10, and 2 zeros means 1000. So here we get the quotient remainder 0. The division is terminating over here. So thus the decimal form of the 127 upon 200, this rational number is given to you. The decimal form is terminating 0.635 is the decimal form of the given rational numbers. Why it is so? Because if you observe, we verify that by our rule, factors of 200 we take 2 into 2 into 2 into 100. Suppose we take factorization over here, 2 into 50, then 2 into 2 into 2 into 25, and 2 into 2 into 2, and then 5 factor, 25 factor is 5 into 5. So 2 and 5. Okay, prime factors are 2 and 5. So therefore the decimal form is terminating. There is no factors other than 2 or 5. That is also by rule we can observe over here. Please write down. So the next sum is given to you, 25 upon 99. If you observe, the denominator is 99, and if you take the prime factorization of 99, we get the factors other than 2 and 5. So therefore, by observation also we can take that it is a decimal form of this number is a non-terminating and recurring. But we have to do actual process over there. Actual division should be carried. Then we can get the decimal form, because the question is there that express the rational number in decimal form. So 99 is divisor and 25 is the dividend. We take the group of zeros after the point, 25.00000. Okay, 29 zeros. If you observe here that we just carried over here, 99 zeros are 0. So first question is 0. Point is given to quotient section. Then we take 0. We get a dividend 250. So 99 twos are 198. we get 52 as the remainder. If we add 0, then we get the new dividend, that is 520. Then table of 99, 99 5s are 495. We get remainder 25. And if we add 0 to that, we get new dividend 250. So if you observe here, we get the remainder 250 again and again. So we carry the division further one more time. That 99 2s are 198, remainder is 52, getting 0, new dividend is 520. Again 99 5s are 495, then we get remainder 25. Again we get remainder 25. So we show it for the confirmation, and then it is confirmed that the after point, the digits 2 and 5 are recurring, means coming again and occurring again and again. So therefore, this decimal form is non-terminating and recurring. So 25 upon 99 is equal to 0.2525 dot dot dot, and the final answer we got here. As we know that for recurring digit or group of digit, we take a bar over there. So bar on the upper side of the 25. So we get the decimal form here, that is 0.25. Okay. The third sum given to find the decimal form, that number, rational number given 23 upon 7. Now prime factorization of 7 is we get other than 2. So it is also non-terminating and recurring form. It will be. So as 7 is the divisor, 23 is the dividend. So we take 0.00 for our further division. So 7 3s are 21. So we get 3 in the quotient and point is given on the quotient section. 23 minus 21, we get 2, then 0, 20. So 7 2s are 14. Here we get 7 2s are 14. Remainder is 6. If we add 0, we get new dividend. So 7 8s are 56. Okay. 7 8s are. Then we get 4. Again we add 0 to that, 40. 7 5s are 35. Then we get 5 over here. We take 0 over for our dividend section. Then we get 7 7s are 49. We get 1 as the in quotient section. We write down 7 3s are, then point, then 7 2s are 14, 7 8s are 56, 7 5s are 35, and now 7 7s are 49. We add 0 to get the dividend. We get 7 1s are 7, remainder 3, 7 1s are 7, remainder 3. Again we can carry it out by taking 0 over here. 7 4s are 28. 7 4s are 28. Then we get 2 as the remainder. And this process will be carried on because again we get 2 as the new dividend. We can get 20. So this would be recurring now. Up to this, these numbers would be now recurring. 7 2s are 14, 7 8s are 56, then 7 5s are 35, 7 7s are 49, 7 1s are 7, 7 4s are 28. This would be again and again occurring in the quotient section. So therefore, the decimal form of 23 upon 7 is equal to 0. Not 0.3 point. By mistake I write down here. So 3.285714. And if you carry again this, this would be carried again and again. So we can write down by taking the sign of G bar. 285714. This group of digits occurring again and again. For that we take the bar on the head of that group. 2 8, 5, 7, n, 4. So this is the non-terminating recurring decimal form of the given rational number.